I think I'm audible and visible. So, welcome to this session. After so long, I'm taking this session on some of the images of your Robbins and other books, like which are important for a NEET PG as well as USMLE. Okay, let me know if you are comfortable with this interface, and I believe you learn well when the teacher is in front of you. Okay. So, image discussion series for NEET PG and USMLE. In this series, we are gonna discuss a few images, not very long lectures like your anatomy marathon and your biochemistry marathon. There are plenty of things which are there in my channel and available to you. But in this lectures, we are just discussing the I will show you an image, okay, which will be like supplemented with your MRI findings or your gross, okay, of pathology, and you can just pause, observe, and answer. Okay, it's not a live class, but you can just shout out loud. Okay, I believe you will remember forever. Okay, so today we are gonna do some of the rosettes, which are like Homer White rosettes and other things. Okay, and few tumors of the CNS tumors, as well as your bone tumors. Okay, so this is the part one of the image discussion series, and in future also I'll be bringing out such series for you for all the subjects. A lot of things and time is not uh, permitting many things to be done. Okay, and okay, so let's not talk much and start. So the first image, you can just observe the first image. This is an MRI finding and the microscopy. Okay, basically in let me give you a hint. In this disorder, the MRI findings are very characteristic. Okay, you can see a very characteristic pattern of MRI finding in this disorder. And here also, if you observe, you will find a like specific thing which is seen in many conditions, but if you supplement it with the MRI findings, then it is just characteristic of this disorder. Okay, can you just identify? Okay, you could identify, well and good. Otherwise, I am telling this, both findings indicate that the patient has glioblastoma. Glioblastoma. Okay, glioblastoma. You can see a very characteristic pattern which is called as a butterfly appearance. Okay, you can just note a butterfly like this. Okay, a butterfly appearance of the MRI, which is indicative of your glioblastoma. And in the microscopy, if I just observe, then the cells, you can see they are arranged fence like. Okay, like you can see a fence like pattern. A fence like pattern in pathology, in a fence like pattern indicates a palisading pattern. Okay, a palisading pattern, but here you will see a pseudo palisading pattern. Okay, in glioblastoma you can see a pseudo palisading pattern and a area of central necrosis, okay. Okay, so you can see here it's an area of central necrosis. This pattern is called as a pseudo palisading pattern. So if you are a NEET PG aspirant, you must have read about a lot of things regarding the glioblastoma. It's a grade 4 tumor, like very poor prognosis. Okay, a very poor prognosis is just a grade 4 tumor according to your WHO. Okay, and if I just give an introduction about the immunohistochemistry. Okay, so you will have your GFAP positive. Okay, a GFAP positive is just generalized. Like GFAP is positive in all your gliomas. Okay, and glioblastoma is one of them. So you can just correlate with the MRI findings with the microscopy and the immunohistochemistry. Okay. Now let's move to the next pattern. Identify the fibers. It's a very characteristic fiber. Okay, you can just look and see. Tell it if you know. This one is your Rosenthal fibers. Okay, this one are your Rosenthal fibers. And can you say in which disorder your Rosenthal fibers must be present? Any disorder that comes to your mind. So Rosenthal fibers are a characteristic of the disorder which is called as a pilocytic astrocytoma. Okay, it's a characteristic finding of your disorder which is a, just a if you have read in both the topics, like you have completed your bone tumors, your CNS tumors, okay, you must have read about the pilocytic astrocytoma. It's a grade 1 tumor. Okay, grade 1 tumor, and majorly it's present in the children. Okay, it's in children. So in pilocytic astrocytoma, we have our Rosenthal fibers. You can see the pinkish fibers, okay, which are these projections. So these are your Rosenthal fibers. Let's move ahead to the next one. You can see a very well defined rosette. Okay, like what is a rosette? Rosette is just a arrangement of cells. Okay, a arrangement of cells, like arranged like a just circle. Okay, it may have a lumen or it may not have a lumen. Okay, like some rosettes are there which have a lumen. If the lumen is present, we call the rosette as a true rosette. True rosette. If you don't have the lumen, you can see the lumen is a whitish streak in the microscopy. Okay, here you can see it is not a true rosette. Okay, because here we don't have lumen, but here look at this, we have the lumen. Okay, so this is a true rosette, and this one is a false rosette. Okay, false rosette, which don't have lumen, in which lumen is absent. Okay, if lumen is absent, it is a false rosette. Okay. And this rosette, if you know, has a very characteristic name. Can you think of it? Yes. Okay. This one is called as a Homer Wright rosette. This one is called as a Homer Wright rosette. Homer Wright rosette. And this Homer Wright rosette is very characteristically present in a disorder which is called as a medulloblastoma. Okay. And it may be found in another disorder. Can you just say? Yeah. This is neuroblastoma, which you have must have read. I'm sure you have read in your childhood tumors. Okay, neuroblastoma. Don't skip these chapters like your environmental pathology, your childhood tumors, and there's plenty of things like in childhood tumors, okay, in disorders of infancy and childhood. If uh, if you know about Wills tumor, if you know about some other peripheral things, okay, it's more than enough. But don't skip. Okay, and in environmental pathology, you must have a general idea of your lead poisoning, mercury poisoning, arsenic poisoning, and etc. things. Okay, and about smoking, obesity, what are the effects? Okay, just general things. You must have read in your biochemistry and all. But don't skip this. If you've seen Robbins, it is exhaustive, I know, but do try to read. So this is Homer Wright rosette, and I said in which disorder it is found? Medulloblastoma. Okay, medulloblastoma, which is a CNS tumor, and it is also found in your neuroblastomas. Neuroblastomas. Okay, so this is about your Homer Wright rosette. Okay, and you can see it is a false rosette because there is no lumen, so it is a false one. Okay, let's come to the next one. If you have seen this picture somewhere, okay, you can well identify this rosette as well. So this one, then could you identify? This one is called as a Flexner Wintersteiner rosette. Okay, FW rosette or your Flexner Wintersteiner rosette. Flexner Wintersteiner rosette. Okay, and Flexner Wintersteiner rosette is present in disorder which is called as a retinoblastoma. I'm sure you must have read about all the features of retinoblastoma. I'm not going into it because we have to keep these videos very crisp and to the point. Okay, we'll discuss 10 images, not more than that. Okay, but it should be like good yield. And retinoblastoma is basically a disorder when is RB gene is, about phosphorylation of RB gene, unbound form, transcription factor 2F, and all the things. Okay, and retinoblastoma is a childhood eye cancers and all. Okay, so about retinoblastoma, okay, we'll see the flexion of intestinal roots. Okay, now let's go to the next pathologic image. So can you identify what is this? So these are your true ependymal rosettes. Okay, you can see it's true because we have the lumen present. You can well observe. Here are our lumen. Okay, so this is a true ependymal rosette. True ependymal rosette. And of course, you can just guess the disorder. It is present in your ependymoma. Okay, true rosette, lumen is present. This one, a very characteristic one. If you know what is this red stuff, you will just well identify this rosette. Tell me. Okay. So this one is a perivascular pseudo rosette. Okay. Perivascular pseudo rosette. And perivascular pseudo rosette is present in two disorders. One of them is the same ependymoma in which you find this true ependymal rosettes. Okay. So this is also present. It is also found in ependymoma. Plus another disorder which is your Ewing's sarcoma. Okay, Ewing's sarcoma. So these are your two disorders in which your perivascular pseudorosette. Perivascular pseudorosette is basically just a basic concept, like you have the blood vessel and surrounding it are the tumor cells and all. Okay, cells. Okay, these are your perivascular pseudorosettes. Okay, this one. Can you tell me what is this? Can you relate and tell me what is this with this pattern? This one and this one looks familiar, right? Familiar. Can you identify? Okay. This one is your palisading. It's same palisading pattern. Okay. Very characteristic. Palisading squam cells. Palisading squam cells. I gave you a hint. Can you tell me the specific name? The specific name of this palisading squam cells. It is called as your Verroque bodies. Okay. Verroque bodies. Verroque bodies. We have something like squam cells just are arranged like this. Okay. The body type of structure incomplete though. It's called as the Verroque bodies. Okay. And can you guess the disorder? Very simple. Present in a squamoma. Schwannoma. Sorry. Schwannoma. Okay. And in the microscopy of schwannoma, we have something called as your Antony A areas. You must have read. Okay. Antony A areas, Antony B areas. Antony A areas are your areas of hypercellularity, and Antony B areas are the areas of your hypocellularity. Okay, and this Verroque bodies comes under your Antony A areas. Antony A areas. Okay, it's an area of your hypercellularity. You can see the cells are closely arranged. Okay? Cells are closely arranged, so it's an area of your hypercellularity. If you want this file to be posted, do tell me in the comment section, because sometimes I forget to post the notes. Okay, and do tell me if you want this annotated PDF of the pictures. I guess I'm not making a mess in this. Okay, no problem. Let's move ahead. Eighth picture. So we are just coming to the end. Okay, it's a very short lectures. Okay, very short and crisp lectures. Can you tell me, looking at both of this, if you can identify? Let me give you a hint. A disorder which is characterized by your painful joints, small joints are most commonly affected. Okay, let me put it in this way. You have your metacarpophalangeal joint, your proximal interphalangeal joint affected. Okay, MCP is affected, your metacarpophalangeal joint is affected, but your proximal interphalangeal joints are spared. Now, can you tell me? Okay, so you can see here some papillary projections, like these are your papillary projections. And these papillary projections are very characteristic of the disorder which is called as a rheumatoid arthritis. Okay, by this I can say this is a microscopy of your rheumatoid arthritis. Generally, autoimmune, small joints are affected. We have genetics for this also. Okay, and you must have read about the formation, about the fusing. Okay, a very characteristic sign of this rheumatoid arthritis is a term called as a morning stiffness. Morning stiffness. Morning stiffness is a very characteristic finding of this disorder, because in rheumatoid arthritis, what happens? Let me take another page and just tell you something interesting. Mm, let's take this. Okay. So in rheumatoid arthritis, what happens is that here we have the bone. Okay, we have this synovial lining of this bone. Let's take the synovial lining in this way. This one and this. Okay, this is the synovial lining of the bone. So what happens is that in case of the rheumatoid arthritis, you will see the formation of pannus. Okay, pannus formation. This synovial linings, this generally swell up and form this projections, which is called as a papillae. Okay, papillary projections. We saw in the microscopy, papillary projections are formed. Okay, here what happens is that this joint cavity is stressed up. Okay, this is like this, and here you will see some papillary projections. Okay, and this will be like expanded. This will be expanded. This will be expanded. And in this papillary projections, you will see the infiltration of leukocytes. Okay, not leukocytes, lymphocytes. Sorry. And what is the microscopy of a lymphocyte? If you see a lymphocyte in the tissue biopsy, let's say, what you will observe? Like, how does it look? Robbins uses a term, a very characteristic term, small round blue cells. Okay, these are called as a small round blue cells. And these projections are your papillary projections. Is there a chance of calcification? In rheumatoid arthritis, is there a chance of a calcification? Here what happens, antibodies are present, like produced, the self antibodies, autoimmune disorder, the same template. Antibodies are produced against the synovial lining, so it binds and starts a series of reactions which will ultimately lead to a pannus formation. Okay, you must have read about all the things. Okay, I'm not going into that. And papillary projections are there. And this papillary projection and the small round blue cells, this together are called as the pannus formation. Okay, this form a pannus. And what happens is that when you sleep, this papillary projections are intertwined with each other. So let's say this is one and this is another. So this gets intertwined. And if this gets intertwined, when you wake up, you'll feel the stiffness. Okay. This morning stiffness is a very characteristic feature, is a diagnostic feature of your rheumatoid arthritis. Okay, we have something called as a morning sickness, which is a very characteristic feature, this rheumatoid arthritis. Okay, so that's about your rheumatoid arthritis. We have two more things to discuss. Okay, this three triad. Okay, I have given you three pictures of Robbins. You can you just identify what is this? It's a very characteristic appearance seen in the radiology. You might have seen it somewhere or other postings or not, but it's rare. It's generally not seen. Okay, this one. You can see the periosteum of the bone. You know about the periosteum of the bone? If this is the bone, okay, there is a lining. This called as a periosteum. This is a periosteum. So let's say if when metastasis like progresses, it's a malignant metastasis. Okay, let me give you a hint. It is the most common malignant metastasis of bone. Most common malignant metastasis disorder of bone. It's a primary disorder, primary bone tumor. This is called as your osteosarcoma. These three features are very specific for osteosarcoma. How did I look? Look at this. This is the periosteum of the bone. Okay, periosteum of the bone. When there is a tumor growing here, it's a metastatic tumor. So of course it will spread. It will spread like this. And if it spreads, it goes from the bone towards the periphery. Then obviously the periosteum will be just a bulge. Okay, bulged periosteum. We'll see like this. Let's say this is the tumor. Okay, and there is a bulged appearance, a triangular bulge. Can you name this triangle? This is called as your Codman's triangle. What is this? Your this bulge is called as your Codman's triangle. Codman's triangle is a very characteristic feature of your osteosarcoma. Codman triangle is a very characteristic feature of your osteosarcoma. And this metastasis is a malignant metastasis. Okay, here you can see there are invasions. There are areas of invasion. The soft tissue is invaded. Okay, like generally your tibia. This is a tibia bone, by the way. This is a tibia bone, and you can see the soft tissue being invaded by this bony deposits. So you can just generally say that there is metastasis. Okay, there is of course it's a most common malignant metastasis, primary bone tumor. Okay, most common malignant primary bone tumor, osteosarcoma. Okay, and here if there is metastasis, there must be a chance of calcification of your surrounding tissue, of your soft tissue around the bone. So if there is calcification around the soft part of the bone, okay, not the soft part of the bone, surrounding the bone, we call it as characteristic sunburst appearance. So this one you can see like a sun is just spreading its flame. Okay, it's a characteristic, it's a very characteristic. I don't have space to write. Okay, no problem, I'll write here. Sunburst appearance. A very characteristic sunburst appearance. You can observe the sunburst appearance here. Okay, very interesting, right? Okay. Do you have something in the microscopy? What are the microscopic findings of your osteosarcoma? Can you say? Okay. So basically, if you say the microscopy, if you are discussing the microscopic findings, we have something here which is called as a mitotic figure, a ugly figure. Okay, it's a mitotic figure. You can observe the mitotic figure. It's indicated by this arrow. This one, this one. These are your mitotic figures. Okay, and here a very important thing, you must have observed a bone in your normal histology in the first year. In your normal histology, you must have drawn the bones. Okay, so basically, if you have the bone here, okay, so we have your osteo so every osteocytic rim. Okay, around the bone you must have osteocytes are there. In the developing bone, osteoblastic rim. Okay, and in your developed bone, your osteo cytic rim. Okay, this is a normal bone. This is normal. This is normal. But when it becomes cancerous, this rim is absent. This rim is absent. So if you don't have the rim, no rim. If there is no rim, this is neoplastic. Neoplasticity indicated. Okay, you don't have the rim. So you can see here, this is a bone. You can observe this part. This is a bone. And if this is the bone, uh, can you see any cell surrounding it? No. Okay. This is the bone. Can you see the rim? Nowhere. No rim is present. Okay. So this is the microscopy of your osteosarcoma. Let's move on to the last figure. Can you guess this disorder? It's a very, very characteristic picture. Does this patient look like a lion? Mark my words, lion. Okay. So some might look. Okay. So this is called as a leonine facies. Leonine facies. Leonine facies means the lion-like appearance of face. Okay. So why there is lion-like appearance? So basically, what happens is that due to abnormal calcification of the bone, okay, the bone growth of the skull is like haywire. Okay, it grows like metastatically. Okay, okay. Due to this, the face get disfigured like a lion. Okay, this called is leonine faces. Okay, or your lion-like face. And this leonine faces is a very common observation, a very common manifestation of the disorder. Which disorder? Can you name it? Paget's disease. Paget's disease. A undergraduate is expected to know very much like it's very frequently asked. Okay, I can just tell like this. It's very frequently asked. So we have the leonine faces or your lion-like face, the Paget's disease. Paget's disease, which is also called as the osteitis deformans. Okay, it is also called as your osteitis deformans. Okay, where the abnormal, it's generally balanced disorder. What I call a balanced disorder, like there is a loss of coordination. There is a loss of coordination between the osteoblasts and the osteoclasts. Okay, osteoblasts are the bone forming cells, and the osteoclasts are the bone resorbing cells or the bone dissolving cells. So, if there is an abnormal coordination between these two, there is abnormal bone absorption and desorption. Okay, somewhere this balance is altered. Okay, if there is an altered balance, there will be abnormal calcifications. Okay, of the bone, and this disorder is called as a Paget's disease. Paget's disease. Okay. Many etiologies are like Paget's disease. We don't have a particular etiology proposed. Okay, some say it is due to a viral cause, like a paramyxovirus. It may be a viral etiology. Okay, like may be caused by paramyxovirus or a rubella. Okay, and somewhere if there is not viral, some say it is due to mutation. Okay, there is a very common mutation. This is rank ligand. You must have heard this somewhere. Okay, if there is a mutation of rank ligand, it may cause a Paget's disease. So likewise, many explanations are given for the Paget's disease. Okay, or your osteitis deformans, and the patient will present like a drooping skull. The skull will be like a droop. Okay, why there is drooping skull? Because the skull has become very heavy due to this abnormal deposition of the bone. Okay, okay. So there was a call. So I was telling that this is generally due to your viral etiology, or it may be due to your ranking. And I was telling about but the dropping like skull. Okay, the skull will be dropped like that because due to heaviness of the skull, is increased in this disorder. Okay, and these are the proposed etiologies. I cannot pinpoint to an etiology and say it is due to this. Okay. And if you see the microscopy, we have something called as a mosaic pattern of bone. Mosaic pattern. Mosaic pattern of bone, which is very characteristically present in this disorder. Generally, your bone marrow stroma, like if I just assume this is my bone marrow, if the stroma of the bone marrow like this, okay, you have space allocated for the bone marrow. But here in this disorder, the stroma proliferation is high. So the stroma is generally arranged in clusters. Okay, there is no bone marrow space left now. No bone marrow space left. This looks this looks like a mosaic, like right. You can just observe. This is a picture of your robins, and this one is from your internet. So this is a mosaic pattern of bone, and this mosaic pattern of bone is associated with your Paget's disease. Okay. So with this, we come to an end of the image discussion series of part one. Okay, and today I discussed what I discussed about some CNS tumors, about some CNS tumors, and some tumors of your bone. Okay, about the rheumatoid arthritis, osteosarcoma, and Ewing sarcoma. And all. Ewing's I didn't discuss probably, right? So with this, we come to the end. So I hope you liked the lecture. Um, these are your high yield images, which undergraduate is expected to know. Okay, and in future lectures, we will be taking up some more amazing images of your Robbins textbook and other hematology books. Okay, and do tell your demands in the comment section, which part of your MBBS curriculum or some revision series if you want to. And I'll be focusing more on your short videos now because I've been doing marathons from last year itself. Like the videos are very long, but high yield, of course. Let's see. So that's all about today's discussion. So thank you, and this is Biswanath signing off. Bye.